Hello everyone and welcome to PadhaiX. In this video, we're going to solve NCERT Class 11 Physics question number 3.16 from the chapter Motion in a Plane. Before we begin solving the question, let's first understand what it is asking. This question is based on the concepts of circular motion, velocity, and acceleration. It contains 3 statements, and for each one, we have to decide whether it is true or false, along with the correct reason. So let's read each statement carefully. Part A. The net acceleration of a particular motion is always along the radius of the circle towards the center. Part B. The velocity vector of a particle at any point is always along the tangent to the path of the particle at that point. Part C. The acceleration vector of a particle in uniform circular motion, averaged over one complete revolution, is a null vector. Now that we've understood the question, let's analyze each statement one by one and find the correct answer.
First, we'll solve part A. The statement says, the net acceleration of a particle in circular motion is always along the radius of the circle towards the center. This question is based on circular motion, so before solving it, let's briefly understand the 2 types of circular motion. A circular motion can be of 2 types, uniform circular motion and non-uniform circular motion. In uniform circular motion, an object moves along a circular path with constant speed. Notice that I'm saying speed, not velocity, because although the speed remains constant, the direction of velocity keeps changing continuously. In non-uniform circular motion, the object still moves along a circular path, but its speed keeps changing with time. Now let's look at the characteristics of acceleration in both types of circular motion.
In uniform circular motion, the acceleration is always directed along the radius of the circle, towards its center. This acceleration is called centripetal acceleration. Remember, this centripetal acceleration continuously changes the direction of velocity and keeps the object moving along the circular path. Now let's come to non-uniform circular motion. Here, the acceleration has 2 components. The first component is the centripetal acceleration, which acts towards the center of the circular path. The second component is the tangential acceleration, which acts along the tangent to the circular path. Notice that this tangential acceleration is responsible for changing the speed of the object while it moves along the circular path. Therefore, the net acceleration is not always directed towards the center in all type of circular motion. Hence, statement A is false. Now let's solve statement B. The statement says, the velocity vector of a particle at a point is always along the tangent to the path of the particle at that point. Here, we need to analyze velocity at a specific instant. We know that velocity v is equal to dx by dt, where x is displacement and t is time. Since time is a scalar quantity with no direction, the direction of velocity is always identical to the direction of displacement. Here, dt means a very small time interval, one that approaches 0. Let's visualize this. Suppose the ball is initially at point A. At this point, this arrow represents the tangent to the circle. Now, let the ball move for a time interval, delta t. After this time interval, it reaches point B. This straight line joining A and B represents the displacement of the ball during the time interval, delta t. Now, let's reduce the time interval. The ball reaches a new position, say point C, which is much closer to point A. This becomes the new displacement vector. If we reduce the time interval even further, the ball comes closer and closer to its initial position. Accordingly, the displacement vector also keeps changing its direction and coming closer to the tangent. So what do we observe? When the time interval is finite, the displacement is along the chord joining the 2 points. But as the time interval approaches 0, the displacement vector gradually becomes tangential to the circle. Since the direction of velocity is always the same as the direction of displacement, the velocity vector also becomes tangential to the path at that point. Therefore, statement B is true.
Now let's solve statement C. The statement says, the acceleration vector of a particle in uniform circular motion, averaged over one complete cycle, is a null vector. Earlier, we saw that there are two types of circular motion. Here, we'll focus only on uniform circular motion. For uniform circular motion, the only acceleration present is centripetal acceleration, which always acts towards the center of the circle. The magnitude of centripetal acceleration, a subscript c, is given by v squared divided by r. Since the speed remains constant, and the radius is also constant, the magnitude of centripetal acceleration remains constant throughout the motion. However, as the particle revolves around the circle, its direction continuously changes, always pointing towards the center.
Now, observe the acceleration vectors at different points on the circular path. At every point on the path, there is a diametrically opposite point where the acceleration vector is equal in magnitude but opposite in direction. Vectors in opposite directions cancel each other. As a result, when we add all the acceleration vectors over one complete revolution, their vector sum becomes 0. Therefore, the average acceleration vector over one complete cycle is a null vector. Hence, statement C is true. And with that, we have successfully solved NCERT Class 11 Physics question 3.17. If you found this step-by-step visual explanation helpful, please hit the like button, share this video with your classmates, and don't forget to subscribe to PadhaiX for more simplified NCERT physics solutions. Thank you so much for watching, and I'll see you in the next video where we solve question 3.17.